Hi, Ewan wanted me to go through a really good one, the Red 14 from Mixed Practice 9, and it's an absolute classic of its type, as in it's just do what we've talked about. So the question says the shortest distance from the point -1, 1, 2 to the line with equation r equals 102 plus t lots of that. Well, the starting point for me is always a diagram. So my starting point is going to be a straight line which goes through a fixed point, 1, 0, 2, and has direction -3, 1, 1. Okay, so the r equals 1, 0, 2 plus t lots of -3, 1, 1 matches our format for straight lines, which is r is a plus some scalar multiple of that. Also onto the diagram, I'm going to mark the point -1, 1, 2. -1, 1, 2. Doesn't hurt to give them labels. I'm going to call the known point on the line A, because I'm calling the A there generally, and I'm going to call that P for point. Right, the shortest distance from the point to the line is this distance. It's a perpendicular distance. How am I going to work out that? I keep reverting to my favourite way of doing these. I'm going to say, because I know those 2 points, I can work out that vector AP. Okay, I can work out that angle if I can work out that vector and I know that direction. What are we trying to work out? This distance. Since that's a right angle, this is a right angle triangle, and I can write that D is AP, no arrow, nothing there. AP is the length of AP, okay? Sine theta from our SOHCAHTOA work. So what do I need to work out? Let's think. To work out the length of AP, I need the vector AP. Vector AP to go from 102 to -112 is 1 to -1 is -2, 0 to 1 is 1, 2 to 2 is 0. I know that I want the length of that, so at the same time I'm writing that AP is mod AP is 4, 1 √5. Okay, right, just move my Sharpie collection further away. Right, to get that angle there, to get theta, we're going to use the dot product. So I'm going to do AP, the vector, so not the length, AP, the vector, dotted with, so that vector dotted with this direction, -3, 1, 1. Okay, so I'm going to dot -2, 1, 0, dot that with -3, 1, 1. And already I'm happy because that's a pair of negatives, a pair of positives, and a 0. I know I'm going to get a positive answer. A positive answer means I will get an acute angle, and you can think about how I know that. Anyway, -2 times -3 is 6, 1 times 1 is 1, 0 times 1 is 0. Okay, 7. Right, cosine theta is that dot product, 7, divided by the length of AP, √5, and I need to do one more bit of working, don't I? I need to find the modulus of the -3, 1, 1. -3, 1, 1. I need that length. Square that, 9, 10, 11, √11. √11. Quick look at the question. Do they want an exact answer? Or they just want an exact answer? They just say an answer, but we might show off here and find an exact one. So cosine theta is that. Therefore, it's sine theta I want. Remember, I've already got AP. It's √5 Look at how I'm respecting the vector. Right. Therefore, sine theta is the square root of 1 minus this squared, 49 over 55. Because sine squared theta and cos squared theta is always 1. Okay, a little bit of knowledge goes a long way here. So that is 55 take 49 is 6 over 55. Root 6 over 55. And I'll tidy all this up later. Therefore, D is AP sine theta. AP, root 5, times that, root 6 over 55. The root 5's cancel. Root 6, root of 6 over 11. We hate thirds in denominators. Let's multiply top and bottom by root 11. Root 66 over 11. Clearly what we could have done is here we could have turned that into an answer. So we could have done cos minus 1 shift cos of, turn that into fraction, 7 over root 55, and got 19.3. And we could have said D equals root 5 times sine of 19.3. Root 5 come out of the square root times sine of the previous answer is that 0.74. Oh, should we check if that's the same? Root 66 divided by 11, is that same answer? Let's check in the answers. Mixed practice 9. Actually, I'm not sure why I'm videoing me checking the answers. You could be doing this, couldn't you? But it's always the exciting bit. Have I wasted 8 minutes of video? 9B. Oh no, mixed practice 9. Mixed practice 9. Mixed practice 9. Oh yeah, root 66. Root 66 over 11 to give an exact answer. Right, well that was worth doing that then for. Oh, at that point, drop the dick. Right then, no one else asked for any questions, so the next thing I want to do is just talk a little bit about actually what the dot product is working out, okay? So let's say that, and hopefully you're all watching this. Some of you never message me to say whether you're enjoying things or otherwise, but that's your decision. Let's say that we had vector A was 2, 1, 3, and vector B is 4, 2, 7 for argument's sake. So we've got two vectors. Let's say they're emanating from the same point. So we've got a vector of 2, 1, 3, and we've got a vector of 4, 2, 7. Okay. When I work out A dot B, we get 2 times 4, so we get 8, 2, 21, so we get 10, 31. What on earth have we worked out? When we say that A dot B is mod A mod B cos theta, what are we saying that is? Right, if I put a theta in there, mod A, so this is the A, mod A is this length, isn't it? That length, the length of that vector is 4 plus 1, 5 plus 9, root 14. When I work out mod A cos theta, I'm working out a length here. I'm working out what's called the projection. Is the projection of A on B. I'm working out if I split that vector into a pair of components parallel to B and perpendicular, this parallel component would be this answer here. Okay. When I multiply that by B, I'm combining the effect of this one in that direction with that one. Now, similarly, you're saying why A not B? If I worked out mod B cos theta, I'd actually be working out this length. Mod B cos theta is the projection of B on A. Is there a use for this? There's a use for everything. Some uses are fairly arcane and unexplainable to understand them. This one I can explain. Let's say we had a force 213 and it was acting on an object as the object moved through this vector. So let's say we had a force acting on an object and the object moved under that translation at the same time. F dotted with x, so this vector for a force, this vector for a displacement gives us 31, a scalar, okay? What context could we possibly give to that? We have previously said, I'm going to change pen, we've said in scalar notation, and see if hopefully you can guess where this is coming. We've previously said that a force multiplied by a distance is work done, which we've measured in joules. We've previously taken these two vector quantities and ended up with work done, which has the same units as energy, which hopefully you're all screaming at the screen, which is a scalar quantity. We will use the dot product in 3 dimensions to work out the work done by a force in 3 dimensions as it moves through this translation in 3 dimensions. So newtons, meters, joules. Now, some of you people are also saying, hang on, wasn't there a context where if we knew a force and we knew a displacement to a pivot, haven't we also said that force times x is the moment of a force? Yes, we have. And when we do this in vector form, we're going to use the other product, which we have not yet done, which is called the vector product, because the answer is a vector, F crossed with X in the right context will be the moment of a force. F dotted with D, notice they're both displacements, in the right context will be the work done. Okay? But here we're talking about a force and a displacement to a pivot. Here we're talking about force and a displacement moved through. Right. I hope that has made some sense. That's just over the 15 minutes. If, and I hope you have done, you've been working through mixed practice 9, ask me if there's any you're not sure about, and I will turn them into a video. That one's for Ewan. Good work, Ewan.